Alright.
And the lowest graded
P6.
P6.
Complex numbers. I is coming back.
No.
Yay.
No. I didn't think there would be I in pre-cal.
Oh, there's
Take
I's
it
in
away.
pre-cal.
Should we just forget all the problems with I in it?
When does an imaginary answer help you in life?
It doesn't.
I equals the square root of -1. It's defined as a solution of an equation. I squared plus 1 equals 0. Okay, I is an imaginary unit.
Oh, this is I have a quick question. So, is this where if we have 1 over the square root of the square root of 1, we just change it to I?
Just the square root of -1 is I.
Wait a minute.
If it's like on top or the bottom or whatever.
But wouldn't it make it positive if you put it on the top?
No. That would be an exponent.
Oh.
Wait. Did I just, okay. This might be stupid or it might be smart, I don't know. But like the reason I is equal to the square root of -1 is because it can never happen because the square root is like two numbers. It's like,
You just can't take the square root of a negative.
You just have to.
Exactly.
It's imaginary.
because it can never,
There's no reasoning with it. You just have to remember it.
no, but like because like the square root of, like you can't have the square root of like -25 because 5 times, like you can never multiply something by itself and have it be negative. 'Cause
I mean, yeah, that's
if there's two
essentially why.
negatives, it's going to be positive. It's two positives. It's going to be two positives. Am I like, I don't know.
Let's just continue with the learning.
Alright.
Over here is real confused. The trying for
Complex numbers, any number that can be written in the form a plus bi, where a and b are real numbers. Okay, this notation means that a and b are elements of the real numbers. Okay,
Is I a base or is it times B?
what?
I's imaginary.
B times I.
Okay, I just didn't know if it was like, you know when there's like exponents on the bottom? I don't know what they're called. I'm pretty sure they're called bases. Is that not what they're called?
Wait. What's that being?
Like 2 raised to the 4, 2 is the base.
Oh, then what's the number that's under it? Like if you had an A and then
It's like a subscript.
Oh yeah.
Oh, yeah. Okay, I was like, I don't know what you're
Wait,
talking
I have a
about.
question.
Yes.
What is that fancy? What's like after the A, comma B?
This, it means element of.
Oh.
Can I just?
Am I right, element of?
Yeah, that's fine. That's just shorthand notation. That
Element. Are we supposed to know that though? Like, are you gonna ever?
Wait, and what's the R?
I just will use the notation every once in a while, but
What's the R mean?
real numbers.
Yeah, we're just gonna write it in words because I'm not.
I need an index in the beginning.
The real number A is the real part. Surprise, surprise.
Whoa, that's crazy.
The real number B is the imaginary part.
It's got an I. See? It's not that bad. We got it, guys.
Yeah, we got this part.
And A plus BI is standard form.
No. It's not really.
All right. Any real number A is also a complex number. A plus 0i Therefore, okay, remember that's what the little triangle thing made out of dots means. All real numbers are also complex numbers.
So the 3 dots means therefore.
Yeah.
Sometimes I can follow like along with you when you write and you're saying it, but then sometimes I get behind and it really just takes me. Is that O? A plus O I?
I think it's a 0.
0.
Never use O because it can be O and 0, and then you're like, I don't.
Well, then my smart self using U's and V's.
Literally, you should have seen me watching one of the videos. I was like, A, U, and I was like, hold on. And then I was like, oh wait, this makes sense now. I literally had to like go back and read.
All right. So if A is equal to 0 and B is not equal to 0, then A plus BI becomes BI and is an imaginary number.
That makes sense.
Okay, so it's complex if it has both pieces. Okay, if it's just the imaginary part, it's an imaginary number.
So
Why
what
would
does
you
that?
rather be complex?
So what does it mean? Like if it's just imaginary? Oh, you're gonna do it.
Well, I was just gonna like throw out like 4i, negative 3i.
So if it's like that, we just leave it alone.
Yeah, that's just an imaginary number. For complex numbers to be equal, both the real and imaginary parts must be equal. Example, x plus yi is equal to 10 plus 7i. Then x is equal to 10 and y is equal to 7.
Is that the equal sign? X plus y I equals 10.
Yeah. There's so many notes in this section. People are gonna hate me. It's gonna be a long video.
Wait,
Oh,
where's
good
the
thing I
other
wrote it
one?
Huh?
Is this the thing where it's like blank is equal to blank, then blank is also equal to blank? The properties we learned yesterday?
No, this is different.
So how do we know y is equal to 7 and x is equal to 10?
Because it says that both parts must be equal. So the x has to be equal to 10, and then the yi has to be equal to 7i. The i's would cancel, if you will. So then y would just be 7.
But y can't equal to 10.
No. Because it's the imaginary part, and this is the real part.
So all the imaginary parts have to equal each other and all the real parts have to equal
All right, operations. Just like adding and subtracting, in general, require like terms. The real and imaginary parts must be positive or negative separately. Positive or negative to complex numbers. This is kind of like a heading here, this one line.
Oh.
If
Is positive and the two complex numbers, positive and negative two complex numbers?
yeah, I'm
It's
gonna
like separately the end of the sentence?
yes.
Okay.
If a plus bi and c plus di are two complex numbers, then the sum of a plus bi plus c plus di is equal to a plus c plus b plus d times I. And the difference, a plus bi minus c plus di is equal to, hold on, I think something's written wrong in my notes before I write it. I want to make sure I'm not going crazy. Okay, there's a mistake in my notes. Don't know why I have it written like that, but
So for the sum, you just put the I at the end?
yeah, touching the imaginary part.
So that
Numbers.
distributes the whole entire,
So the I goes on the B and the D.
because they'll be real numbers, right?
Yeah. They'll be real numbers, but the I makes that the imaginary part.
I literally wrote D like so many times I had to scratch it out in both the sum and the difference in the same place. Like, what the heck? I just can't. Remember, is it?
So does this do like the double negative thing? Where it cancels out, or do you have to wait until after you combine the two?
Double negative.
Like, oh, never mind. It's adding. Don't worry.
Alright, so there's gonna be a couple little identity type things here.
Or maybe, because I'm at the bottom of the page.
Well, for me, it's 6 lines. It's what's written in purple, but I wrote pretty big, so.
I'll just try to
Additive. I'm just gonna say that might be spelled wrong,
Do you
because.
write, okay, because you write in color on your actual notes page. Are you writing in the same colors that you use on your notes on the screen?
Sort of.
I'm just thinking.
Some of the colors don't show up as good, like, for y'all to see in class, so I have to kind of be
So
careful.
how many identities are there?
Well, there's 2, and then there's another thing that goes directly with that, so you
Okay.
probably need 5 lines.
I would just write really small. We go.
Additive identity for complex numbers.
You know, I'm just done.
0 is equal to 0 plus 0i. Real hard. Additive inverse. A plus bi is negative times a plus bi, which is equal to negative a minus bi, because a plus bi plus negative a minus bi is equal to 0 plus 0i, which is equal to 0.
Whoa, this
then all properties of real numbers hold for complex numbers. Just any property that is true for your real numbers, like the ones that we've did a couple days ago, all are still applicable with complex numbers. I'm going to go ahead and just write this one in the same color because I feel like it, but the next thing, it technically was not counted in the 5 lines that I told you. Multiplying complex numbers. You have something like a plus bi times c plus di. That's equal to a times c plus a times di plus b times ci plus bdi squared. Remember that I squared is equal to -1.
Are we gonna do the inverse of this one too?
No.
Or is this like completely separate?
This is like completely separate. This?
Yeah, like are we going to a different section after the multiplying one?
Yeah. Well, I mean, I would typically have done that, and then I would do examples, and then I would do another set of notes. But I'm just going to try to go through all the notes in one video, and I may just tell people, like, hey, at the 20-minute mark, stop watching, and the other part will be the next exercise.
I was trying to get it all on one page. So this is one line left.
So this is equal to AC minus BD plus AD minus BC times I.
Is that it?
That's it for that part, but it's not all the notes for this section.
Okay. Can I either put that or
One thing here that if you still have a line at the bottom and you want to write it, you can. You may not really care, I don't know, but or you can go to your next page and just start on that page. I squared, I cubed, I to the 4th. Okay, the I is obviously just equal to I squared is -1, I cubed is -I, and I to the 4th is +1. Okay, and this continues following this pattern.
oh, I remembered it.
Yeah, I remember not doing that on this page, but it's all, so that's great. Starting off the year with
So if we see the FOILing problem that you have up there, basically, the a plus bi, c plus di, we can just do ac minus bd, or do you have to go through all the steps like that?
You wouldn't have to write that part. You could just come here if you know that.
Maybe we'll do something like taking a lot of concentration about this. Wouldn't the I go away though?
This one did. That's why it's just AC plus or minus BD.
Oh.
But these two still have an I on them, so we just pulled the I out of those.
And that's why they're over there with the I.
Yeah.
That makes a lot of sense. Thank you. Okay. Got a full page again.
All right. Complex conjugates and division. A plus bi times a minus bi is equal to a squared minus bi squared, which is equal to a squared plus b squared. Complex conjugates of a complex number z equals a plus bi is, okay, this is, that little line is symbolizing that we're dealing with a conjugate above the z, is equal to a plus bi, and we're going to put a line over that. Okay, that means we're taking the conjugate of it, which is equal to a minus bi.
I remember how to do conjugate. Like, I've seen them like.
Yeah, I don't even remember that.
Conjugate is just flipping a sign to make things cancel that you need to get rid of. So we did that. We did conjugates with two things. We did it with complex numbers, and we did it with, I'm blanking on the word at the minute, but the numbers that have the radicals in the bottom. Like when you have like the fraction bar, if there's a radical in the bottom,
Yeah, I remember it, but I just.
we did it there too.
Maybe we'll just memorize this and we won't have to go through the steps. It's a lot of
Multiplicative identity
Multiplicative, that's a big word.
for complex numbers is 1 equal to 1 plus 0i. The multiplicative inverse or reciprocal of z is equal to a plus bi is,
Wait, why is the other one in blue? Is there a reason?
I don't
for it?
know.
Oh. I didn't know if
It was all in one color on my other page, I just didn't think about it.
Is that a 1? 1 equals 1 plus OI or 0i? Just making sure.
Yep. So z inverse is equal to 1 over z is equal to 1 over a plus bi is equal to 1 over a plus bi times a minus bi over a minus bi is equal to a over a squared plus b squared minus b over a squared plus b squared times I.
Where did the Z come in?
Z is just the abbreviation that they usually use for like a complex number.
So it'll be a real number? Like, or will it be like,
No, Z is a complex number. Well, I mean, I guess technically it's real, but
will it be like 2i? Is that what
it could be, yes.
And then you do everything like that?
Say plus b2 to the 6th. To the.
Over here,
Yeah.
this is a over a squared plus b squared minus b over a squared plus b squared times I.
This is like really confusing. Did we do those last year?
Some of it, it's kind of an extension of it. So what this means, okay, because it looks kind of big and scary. In short, when dividing by complex numbers, we multiply by the complex conjugate. One more thing. And then, well, one more thing that's like 3 bullet points underneath of it.
Are we gonna do it's gonna be a while until we do examples for this.
Yeah, it's gonna be a little bit.
Like everything else I kinda understood, but this is like confusing, so I was like, can we do examples after? But then we can't because
See, everything else I understood, but it's because I could look at my notes and look at the formula and it's right there, and then I'm like, crap.
can you
I
like
have to know these.
focus it again? Because I can't really read. Oh, never mind, it's just
It's just because it's the light green.
that's fine.
It says in short when dividing by complex
I can
numbers.
I can read it now. It's just it was really light from the candy.
Complex solutions of quadratic equations. So, inside, okay, the quadratic formula, okay, underneath the radical, if you look at the poster, that's why I'm pointing back there, okay, it's got b squared minus 4ac, okay? That is called the discriminant. That is going to tell us whether or not our solutions are real numbers,
I remember that.
okay? Yeah, we should have done this last year at least a little bit. So b squared minus 4ac is the discriminant.
Oh yeah, I do know this one. Because we had to do this to do something else.
Yeah.
I can't remember.
Which tells us whether or not solutions are real numbers. If b squared minus 4ac is greater than 0, then we have two distinct real solutions. If b squared minus 4ac is equal to 0, then one repeated real solution. And if b squared minus 4ac is less than 0, then complex conjugate pair of solutions.
I remember this, and this is what I struggled with.
Alright, so I'm just going to say that you probably, if you've got at least a half a page left, are going to want to leave 2 pages to do examples. I've got a decent amount that we'll go through.
Yeah, this one's
You probably want at least 2 pages of 2 full pages to do examples on.
So like this, and
I would leave it just to be safe because I really think you need more than a page.
I think this is
Yeah,
like the
I'm
biggest
just doing
section
all
we
the
went over
examples
so
at the
far.
end. Yeah, that's what I'm gonna do. I'm gonna do all the examples at the end and then just label what section they come.
Because some of them are like in square roots and like all that.
I feel like